Alright, the next topic is how to solve systems of equations using what we call the elimination method over here. And all a system is, by the way, in this case here, it's two equations in which we have two variables here. So basically we're trying to solve for x and y, and we're also going to state our answer as a coordinate, x comma y, because anytime we have a system here, in this case here, it's going to be, this is a line, this is a line, two lines are going to cross somewhere, and we want to know where do they cross, and that answer is x comma y. So in this case here, you'll notice that neither equation is solved for x or y. So you would not want to do the substitution method here. And so what you can do, though, is you can add the equations together. So for instance, if I add these equations together, I would get 4x, and you'll notice here 2y minus 2y, the y's disappear. There's a 0y there, and then 13 and a minus 1 is 12. So that's great. If you can add your two equations together and one of the variables goes away like it happened here, that's what you want to have happen. So now you divide by 4, and so you get x equals 3. So now we already know half of the answer. We know the x coordinate here. And then what you want to do is just plug it in. So I'll take this first equation right here, and I'm going to write x is no longer x. X is now 3. So I'm going to write 3 plus 2y equals 13. Go ahead and subtract 3. You get 2y equals 10. And if you divide by 2, you get y equals 5. So what's our final answer in this case? Well, it is 3 comma 5. So that's where these two lines would intersect. Alright, so now let's look at another type of equation. It'll be very similar here, but in this case you'll notice here if we add the equations together, we get 3x plus 4y equals 26. So that's a problem because in this first equation here, when we added the equations together, the y has disappeared. We got 0y. Here that doesn't happen. So you do not want to add the equations together in this case. So the question becomes, what do you do? So this is what you do. You can either decide, do I want to get rid of my x's or my y's? The choice is yours. I'm going to choose to get rid of the x's in this case here. So if this is 2x, wouldn't it be nice if this was also not 2x but negative 2x? So the answer is, of course, it would be nice. So what you can do is you can take this entire equation and multiply by negative 2. So if we do that there, what is negative 2 times x? Well, that's negative 2x. And what is negative 2 times 3y? Well, that would be negative 6y. And negative 2 times 22 would be equals negative 44. So by multiplying everything by negative 2, you've changed the equation because it's obviously not the same equation, but it's essentially the same equation because everything has been multiplied by the same number. I'm going to rewrite the second equation here, 2x plus y equals 4. And from here, all you got to do is now add your equations together. So your x's cancel out. Negative 6y plus 1y, that's a 1 right there, would be negative 5y. And negative 44 and 4 is negative 40. And if you go ahead and divide by negative 5, you are going to wind up with the answer for y. So what is y? Well, y is 8. And then you can go back to either equation here. I kind of like the second equation in this case here. So the second equation would be 2x. Y is no longer y is now 8 equals 4. So therefore 2x would equal negative 4 if you subtract 8 on both sides, and divide by 2 you get negative 2. So what's our answer here? It is negative 2 comma 8. So here's a case where we can multiply one equation by a number, get our equations to eliminate a variable here when we add them together. And so the final example I wanted to show you was, well, what happens when you can't just multiply one? Can you multiply both equations here? So I can't just multiply 2 by some magic number to make it 3, and likewise here. So what I'm going to do is I have to decide once again, do I want to get rid of my x's or my y's? And just for fun this time, I want to get rid of my y's. So what's the first number that 2 and 5 go into? Well, the first number is 10. So if this was 10 and maybe this was negative 10, that would work out really well. So I'm going to multiply this one by 5, and I'm going to multiply this one by negative 2. So the first equation would become 10x plus 10y. Now what is 5 times 14? 5 times 14 is 70. The second equation, if I multiply everything by negative 2, I get negative 6x. Negative 2 times 5y would give me my negative 10y. And then what is negative 2 times 23? Well, that's negative 46. Now add these together here, and when I do that, I get 4x equals, y's go away, they're eliminated, and 70 minus 46 is 24. Divide by 4, I get x equals 6. Once again, I'm going to pick either of these two equations here. I'm going to pick probably the top one. It's easier to work with here. So I know my x is 6, so that's a 6 now. So 2 times 6 is 12. So I'm going to write 12 plus 2y equals 14. Subtract 12, I get 2y equals 2. Divide by 2, I get y equals 1. So my final answer, therefore, is 6, 1. So that's how you do the elimination method. Basically, the method is this. You want to eliminate one variable when you add them together, and then from there it's pretty darn easy to substitute values in and find the actual answer.